I tried to come up with a catchy title that, 7 levels of hint invalidity. I'm not even going to try to say it. You see, you can read yourself. So 7 reasons why hints are invalid in Oracle SQL. And okay, and actually, I'll paste the Slack link here once more. Into the chat, because I think people who log in, they don't see old messages. I might actually paste it in later again. Okay, so as I said or actually, let me just go. We'll go on. So I'll just show you this slide. So this is about me. I've already talked about it, so I'll skip that. Actually, if you attended my last hacking session, then right before that, I found that somebody was selling the Korean language version of the Expert Oracle Exadata book for $700, plus shipping in Amazon. So it's just made me feel even more important. So that's cool. So where do you get my scripts? You see, I'm going to use some scripts. These are all in GitHub, right? So that's, you can get them. And a couple of demo scripts what I'm using, I just wrote them like 2 hours ago. So I will upload them to GitHub as well, right? And if there is a help script now as well, so I might use a SQL patch or baseline later on to demo some things, and well, maybe. And but now I have about 100 of my scripts documented in a help.sql. So over 100 documented so far. Okay. All right. So why is such a title like that? Hints are invalid. So as I said, let me go to the documentation as well. So this is Oracle documentation about comments and hints, right? You see, I just actually read this documentation section today again, so I haven't read that part for a while. But you see, this says that the optimizer uses these hints unless there is some condition that prevents the optimizer from doing so, right? So that's why the title, that hints are invalid, or hints can be invalid for a bunch of different reasons, right? So hints are orders to the optimizer. Hints are directives that the optimizer must obey unless some condition exists that prevents it from using it, from doing so, right? Or sometimes even optimizer actually uses and obeys your hint, but something in the bigger picture sort of causes this thing to become invalid, or not the correct thing to do, right? So this documentation, I think it could be better, and maybe it could explain things a bit in a stronger wording, that optimizer must use these hints. But sometimes these hints are invalid because some condition exists that prevents them from doing so, right? So, and I kind of at some point in the past, I sort of tried to categorize these reasons into multiple levels, right? That there are very simple reasons like syntax errors, but there are more complex reasons, right? And I'm gonna go through this in this hacking session, right? Okay. And I don't really want to make this talk about all the different hints what you can use and so on, but I will explain some basics, right? So before we go into this invalidity, it's pretty hard for me to pronounce it, so, especially when you start trying to pronounce it correctly. Invalidity. Okay, yeah, it's hard anyway. So in my own native language, I'm sure I can do it better. So okay, so hints are specified in a comment block, right? So and as you know, or you can even add a hint with you know, because this minus minus is also like a comment, so that anything that comes after this minus minus or dash dash, that's a comment, right? And if that comment has a plus sign here, then you know, then everything all the way to the end of the line is a comment, right? So you can add hints like this as well. This looks cool, but I don't like that this form, because it's sort of I mean, in the upper form I kind of clearly see where the comment starts and ends. This looks a little bit more like a hack to me, you know, even though it works. But when I actually build something real and I actually end up adding hints for some reason, then I don't use these minuses. So it's just to be a bit more clear where the comment starts and where it ends, right? Okay. And the hints must be specified in a single hint comment block right after the you know, select or update or merge or whatever, right, statement. Okay, so you know, for example, let's actually test it out just to be sure that it's actually correct. But you know, let's say you have a with subquery, and you know, usually you do something like this, selects blah blah blah. You know, the comment should go in here, or the hint should go in here, whatever hint it is. But if you sort of incorrectly put the hint in here, you know, this is not correct. And let's validate whether this is true, whether this is still true. But oops. But you know, hints need to be in a comment block, right? And this is actually you know, like one of the simplest levels or hint. Let me just open my Slack and see what's going on here. One of the simplest levels of hint invalidity. Yeah, I trip over this. One of the simplest reasons why your hint is not working is that, you know, it's the syntax is incorrect, you know, of the hint, or maybe you know, it's not in the correct query block, right? So let me show you the. So that's just one example, and I'm actually, when I demo this, you'll see that. So this is one example where you see we have a comment block here, which is not a hint, right? This is just a regular comment because it doesn't have a plus sign here, right? And then we have a next comment block is a hint. Let's say it's a leading hint, right? And next there is one more comment block after that, which also has a plus in it. So that's another hint, but this hint will not be honored because Oracle SQL parser has already found the first hint block, you know, with a plus sign. It will honor or try to, you know, it will parse those hints in this, and it will not look into any other hint comment blocks under this query block. You know, if you have a subquery here with another select and blah, 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 you can put in hints in here, right? So, you know, how do you shape your, you know, comments here and query blocks? You know, that matters, right? And let's see if the documentation says, yeah, okay, so a statement, you know, so you see a statement block can only have one comment block containing hints. So if you need to apply 5 hints, you know, you have to put them all into the same comment block, right? So, okay. So, you know, that's the basics. And this is, again, like, you know, hints are directives. And this is from an earlier version of documentation. Again, hints are directives, they are commands, but sometimes they are invalid for some reason, and then we will start looking into the reasons. Okay, so and we'll in the end, when we get to more complex scenarios, we'll talk about this, you know, how a hint can be sort of invalid under some evaluation circumstances. Okay, so, and I'm just gonna go through as a reference that what we are gonna now demo and then hack. So these are the, I have 2 slides here, right? So what are the levels of hint in invalidity? Yeah. So number 1, the hint is not addressing the correct query block, right? Or like you saw 2 slides ago, if you have multiple comment blocks with hints in them, then only the first one will be used, right? I'll just go through this list quickly, and then we just dive deeper into all of them. Hint name is incorrect. Obviously, when there is no such hint, then if you use a wrong syntax, then obviously the hint will not be used, right? And what helps here is that there is a $SQL hint in Oracle 11G onwards, right? So you see, if you look for a hint that has merge in it, well, these are the valid hints, right? If you use any hint with any other text or any other name, then they will not be used because Oracle doesn't have such hints, right? And on the slide, I will upload the slides as well to speaker deck. So later today, I have a script called hint hierarchy, which uses a $SQL hint, and it uses $SQL feature and $SQL feature hierarchy, right? And it uses like a connect by, and what this gives you is, if you're wondering, like what is the difference? I mean, what is the merge hint? And we use merge. So this is like the version when it was introduced as a hint, and this is the version when it was introduced as an outline capable hint, in the sense that optimizer is able to optimizer is able to construct such a hint if needed for reproducing the plan, like talking about stored outlines or baselines and so on. And the inverse hint is also that, hey, if there's a hint called merge, those hints who have an inverse version, there is like something called no merge, right? And later on I'll show that sometimes what I do is when I want to disable a specific feature kicking in, I can take a whole outline or a whole set of hints from the outline and just replace whatever hint I don't want to kick in. I replace it with a no version, right? There are some gotchas there, but that's useful. And anyway, so before I do the hint hierarchy, you see here is a you see there is a hint called you see here is an example. Like most of the hints nowadays have, like, when the hint is merge, that do whatever this means, do a merge, and the inverse version or the opposite of that is no merge, right? But you see there are some hints from older days where use concat. This means that, hey, convert an in list to a bunch of union alls, essentially, instead of doing an in list search. And the inverse is that no expand. Do not do or expansion of the in list items or into a union all, right? So that's what the inverse tells you, right? But back to the hint hierarchy, you see, if you don't want to read documentation, many of these hints are documented, of course, but if you don't want to, you're not the kind of a guy who wants to read documentation first, then you see hint hierarchy, this is the connect by against $SQL feature, like I showed. You see, that may show you something more, may show you something useful. So for example, the merge hint it's about cost-based optimizer, it's about cost-based query transformations, and CVM is the module. It means complex view merging, right? And apparently, I don't know, for some reason this hint is registered in a couple of different modules in Optimizer. So this is the $SQL feature hierarchy, right? That's where this info comes from, right? That apparently the merge hint is also a compilation transformation. It's a query transformation hint. It's a cost-based query transformation, complex view merging, right? So that's what the merge hint is. But if somebody talks about the use merge hint or no use merge, that's a totally different thing. It looks similar, but use merge is about join methods. It's a sort merge join, right? So merge is controlling view merging. It's a query transformation thing, right? But use merge, like as you see from here, it controls join methods, right? So, and if you do hint hierarchy, show everything percentage, these are all registered hints. You know, some hints are registered in multiple components. Quite a lot of hints, right? And you see some hints are apparently like an runtime thing, in the sense that, you know, should we use prefetching, like array prefetching and so on, when we run the query, and it doesn't really, well, it's considered to be a runtime decision. Although some of these things can change the plan as well. Anyway, so that's what we have, right? And apparently there are some transformation hints which are considered to be heuristic, right? So like you know, or maybe it's like an older version, you know, unnest or no unnest, there is an heuristic component when the decision is so simple. But when I look into this, you know, unnest hint, it's apparently also you know, in newer Oracle versions, or in modern Oracle versions, this decision can also be cost based, right? So again, it's sometimes it depends on the complexity of the transformation in hand, or maybe you know, in some cases this may be just like you know, from an old Oracle version just laying around, right? But it's but you know, if you have a very simple query to unnest, it may be a very easy decision, right? Okay, so you know, because if you have like a I don't know, when you do something like this, so you see, we have an, well, actually it has not unnested this. So, well, actually, so this is a difference. I would need to, I'm not going to go there just yet. So, or actually, so let's see what happens. So if I do this, I run it, and I do the explain plan for the cursor, but I want to show everything, all the output, right? So in this case, actually, so there is no unnesting. We have actually pushed this subquery, because this is like a scalar subquery, right? We are using equality here. So there is, you know, if this subquery returns more than one row, we will get an error, right? So, and therefore, you know, Oracle has sort of pushed this subquery. You see, this is my dual access. This is the select star from dual. You see, because when I do select star from dual, I actually want all columns. We actually have to go to the table. We will go to the physical dual table doing logical IOs. But when I select a constant or a sysdate or something like that from dual, then starting from Oracle 10G, we don't have to go to the dual table. We can use the fast dual. We'll just generate this one row with this constant from memory. We don't have to do logical IOs and full table scans against the dual table, right? Fast dual showed up in Oracle 10G. So I see, and so that query has been pushed to under this table scan, so that we will basically run this query, get whatever value from here, and then we can continue this table scan with whatever value we got from this, from this subquery. Okay, and that's what the push subquery is, right? And maybe I'll just show you straight, you know, what I wanted to say. That, I mean, you should not, like the documentation says, hopefully in the modern days, you don't have to use hints much or at all, or hints are just temporary workarounds, hopefully, not like your everyday development strategy, right? But sometimes when the optimizer seems to be doing something wrong, then well, actually, let me see where the query is now. Okay, so that's a wrong query. I'll just run it once more. So I just ran the query again. So this is the push subquery. Sometimes when the optimizer, let's say it seems to be doing something wrong, then I will take this I can take this hint, and actually let's see what is the inverse version of push subquery, right? So the inverse version of push subquery is no push subquery, right? And in most cases, when you have such an inverse hint, you can just change the hint. You take this hint from this, from here, from the outline section, and then you will, put the inverse version in place, right? There are some cases in modern Oracle versions, like Oracle 18 and so on, where you see the merge hint, the view merging hint actually has expanded its syntax. And if I want to change this to no merge, I will actually have to take this expanded syntax out and only leave this in. So, but it's just a matter of some experimentation, that what is honored and what is not. And this is what this session is about. Anyway, so I just did no push subquery in this case. Let's say that I suspect that this is the problem in my query. And now when I look into execution plan, you see, if I don't actually push the subquery down, then we are using the old sort of fashioned filter loop. So filters are a bit like nested loops, but they're way more flexible, right? And now we will basically see if we get any rows from this table. If we get rows from this table, we will go and check whether that whether this subquery here, whether this returns any rows, and we will do this filtering. We will pass rows up to the filter operation, and it's the filter operation which does the throwing away or filtering rows which don't match this subquery, right? So there's just a bit more movement of shipping rows around, right? And apparently there's some parallel query filter kicking in. I don't know what the heck this is, or in this context. Okay. So so this was like this was basically the explanation of this part. That obviously that when your hint syntax is not correct, then it will not be honored, right? Okay. So the hint name is not correct, right? So, and I'll just do a very quick summary, because before I go deeper, I want to actually show you what's coming. So, there are cases where the hint name is correct, but the parameters are incorrect, right? Like the example, I'll demo this later, but you just say this: select index, blah 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 blah. I mean, yes, of course there is a hint called index, right? But if you forget to add the actual table alias, to that which table should use an index, then this will not be used. Or maybe you have, select full, you actually put the table alias in here as well, but you forget this table alias. You forget to define the table alias. There is no table alias T here. There is only a table alias called my table. So, that if you add an alias to table name, you should use it here, right? Or if you use an alias here, then you should alias your table properly. Then there are cases where your hints, names, and parameters, and the object or alias you're referring to, that these are correct, but the optimizer cannot honor your command because such a feature doesn't exist, in the sense that or the execution engine doesn't support it. So, for example, I haven't tried this on a new version for a while, but let's say that there is an index range scan, but you don't have a filter condition in the query, right? So let's try this. I definitely have indexes on this orders table, and these are the columns what I have the index on. And now I'm gonna say select you know, select some card ID from Zoe. Okay, so when I just run a sum like this, this column is not indexed, right? So if I do this, you know, we get a full table scan, right? And now when I say, well, let's actually go through this. If I say use an index, then this will not be used because my index syntax is incorrect, right? Right? There is no, I mean, we cannot use some index here. My index syntax is incorrect. So, and maybe if I do, I show you the all output. So this section in DBMS explain display cursor. I have a couple of slides about it, starting from Oracle 9i. Not the 9. Oh, stupid! I'm stupid. Starting from Oracle 19c, not 9i. Man, why did I say that? You know, actually, we have a hint reporting available for us as well, right? So there is like an XML fragment or XML section in the other XML. You see, let's take this cursor, look into other XML. You see this. This is where where's the hint section? Hint usage reporting, right? So, and then the DBMS explain can now show that, like, hey, E means syntax error. The hint index was not used because of E, syntax error, right? Anyway, we'll talk more about that as well. So this obviously will not use an index, and now I can just say, like I said previously, if I say this, like I have a table called O or alias called O, and if I look into the hint syntax, you see now it says unresolved, in the sense that this is a different layer. I mean, the hint name is there. Yep, it's correct. We actually add an parameter argument table alias what should use the index. That's kind of correct enough as well. However, there is no such alias like O because I forgot to add O here, right? Or I should just put the table name here, you know, orders. So even though I'm using a schema name here as well, that we will need to ignore the schema name. The table name will become the alias if you know, if I don't explicitly alias my table, right? Okay. And this is now, let's see how it behaves in an older version. You see, now it says that the index was actually honored in the sense that total hints, you see, we are using in this query block, this table alias, and this query block, we are actually using this index. There are no letters like E or anything in here, or unresolved and so on. So this index actually was used. Or in this case, in this version, the index was actually, an index was forced. But actually, I'm not so sure that this is a smart thing to do. And this is a good example of why hinting, it can be bad, in the sense that hinting is okay if you want to work around a specific problem and you know exactly what you're doing, right? And this is why we're doing this session here as well. But if you're just thinking, hey, what about adding? My query is kind of slow. I'm gonna add an index hint. Because indexes make things faster. Well, in this case, the index actually was honored, but the execution engine did something. Well, we forced the execution. We forced the optimizer to use an index, right? And since indexes are, they are directives that will be honored unless there is some condition which prevents it. Well, in this case, we're actually getting a pretty bad thing happening here. So we are using a full index scan on a different index. We don't even have a where clause, right? And if I'm not remembering wrong, in older versions of Oracle, when you didn't have a where clause, then the index hint wasn't honored at all. But let's see. But we can try a different version as well of this. But anyways, this is not a good thing because we're now going through the entire table, one by one in this order of whatever index was picked. We don't even have a where clause, right? So when you're gonna go through the whole table, it's better to do a full table scan, very likely, or a fast full index scan against some index if it has such a column in it. But this particular column is not part of any index, so we cannot even do a fast full scan through some, you know, through such a column in an index. So that's a pretty stupid thing to do. And if you do a set timing on, you know, so this is a fairly small table, but if I now do a full table scan, you see full table scan is like what is it, 20 times faster in this case than going through an index row by row, right? So in this case, actually, optimizer followed my fairly stupid order. Let's because I remember this differently. Maybe something has changed, or maybe something has maybe I remember the wrong thing. This is a hacking session after all. So let's try this. I'm gonna change the optimizer features enabled to a different version. But I gotta say that optimizer features enabled is not perfect. I mean, this does not make your query run on Oracle 11. This will just control some optimizer features where this kind of version specific enablement is implemented, right? So this will make my optimizer work more like Oracle 11, but it's not gonna be exactly Oracle 11 because some features in the optimizer don't have this feature flags enabled, right? And it looks like that even when I set this optimizer features enabled to smaller, this index is honored. And I guess that index, that hint semantics could be explained as, you know, at least based on these tests, that if I use an index hint, use whatever index, even if there is no where clause. So this index hint was used, but if I look into hints, you see, if I really want to control what's going on, and if I look into the outlines, if you look into the outline hints or the, you know, hints in the baselines and so on, you see there are a lot of different index hints which are more specific, right? And actually, if I want to do an index range scan, right, that's the hint what I should use. Like do an index range scan ascending, right? And this is usually what you would see in an execution plan as well. Let me see what we have here. So, okay, in this case we have an index without any further, you know, because, you know, this. Yeah. Anyway, let's do this. I want to show you that if I really want to be correct, that I don't want to say that, hey, use just index in any way possible. But I want to really be correct that, hey, use an index range scan on an index on this table, right? Well, now it was suspiciously fast. And when I look into this, you see, we got a full table scan. This index was honored. I mean, this index was found. The index, there is such an index with this name. The syntax was sort of correct enough, you know, because sometimes you can have more arguments in the syntax, but the syntax was correct, but this index was not used. So this used or not was not a cost-based decision. It wasn't like, hey, maybe I'll use it, maybe I don't. It was that this index says that you must do a range scan on this. You know, you must do an index range scan on an index and find exactly only those values you're looking for, right? But our query doesn't even have a where clause, right? So this index was unused. So let's just do this. So where card ID is bigger than 0, right? So now I'm gonna add this column in here. So you see where card ID is bigger than 0, but the index is still unused. Or this hint is still unused because we don't have such an index, right? So, and that's when let's now create such an index. So create index blah on so a small orders card ID, right? Okay. So now let's run the same thing. It's a bit slower, but probably because the index blocks were not cached. You create an index, with direct path writes and so on. So on the first run, everything is not cached. But let's see what happens. So you see, now we have an index range scan. So now this hint is finally valid. The name is correct, syntax is correct. We actually have a where clause, and we actually have such an index. Now this index is finally valid, or now this hint is finally valid, and it can be used. And you see now it shows that yes, this hint was used. There is no letter like unused or syntax error or anything like that in before. Okay. So, and just to finalize this, let's see what happens if we don't have any hints at all, right? Well, if we don't have any hints at all, Optimizer realizes that, hey, we're going to go get most of the rows. You see, if I look into the table, the orders table has, so this is the wrong schema, small, right? I have a small order entry schema. So we have 1.4 million rows in this table. And since I'm looking for all rows, really, Optimizer sees that, hey, we estimate to get all the rows anyway. So we are not gonna, we're not gonna do an index range scan looking up rows one by one, right? It makes sense to do a full table scan on the index segment. This is what an index fast full scan essentially is. It's like a full table scan, but on the index segment, because all the columns we actually need are right there in the index. Okay, so if I did this, right, like, hey, let's take only a very small portion of rows, then of course the optimizer will estimate that, hey, we're going to get only 32 rows out of, 32 rows out of 1.4 million. Therefore, it definitely makes sense to use an index range scan and look up only those rows from this index what we wanted to. And interestingly, you see we have an index hint here. It doesn't show index rs ascending, which is a bit interesting to me. But I'll leave this where it is right now. Okay. So obviously, Optimizer, if you don't force it with a valid hint, then the Optimizer will decide what to do based on the cardinality estimates and how big your table is and so on. It tries to find the path of lowest effort to your data. And now let's finalize this by, let's do this now. So I don't have a where clause like when we started, okay? When I don't have a where clause, obviously I don't have any hints. And you see, I don't have a where clause, but the column that I'm selecting, you see the projection, the column that I'm selecting from this object, that's part of this index, that's in this index. So instead of doing a full table scan through a fat table, we're going to do a full table scan through a skinny index on that table. Okay. And yeah, actually, Giles, thanks for reminding me. I forgot to set the optimizer features enable back, so I can just say, was it? Yeah, I think it was that. All right, so let's set the optimizer features enable back, and when I have this, let's see if I still get this index, right? But anyways, it was a good thing to switch that back. Okay, and I wanted to finish by, where we were was this, right? So we get an index fast full scan, that's great, because now we actually have an index. We're not trying to make something out of nothing. We actually do have an index. But what happens if I do index index, what if I use an index hint? Does that change anything? Or let's see. I don't know all this stuff off the top of my head either, but I just experiment. And it's often pretty easy to experiment and see what happens. You see, I used an index hint, and now I get an index full scan again. So that's bad news, right? So now we are going through the whole index. So index full scan is like an index range scan from end to end of the index, from one end to another end of the index. Index fast full scan is like a full table scan on the index segment, right? So they're different things. So you see, the index hint is kind of bad. So if I actually want to force fast full scan, then I should use index fast full scan, right? This hint. So now it's index fast full scan. Sometimes you want to do that. So, and if I do index rs ask now, so this is like, hey, I want to do a range scan on this column. And this column is indexed, right? So apparently, you see what happens here, okay? I forced an index rs ask to a range scan, but I don't have a where clause, right? And if I don't have a where clause, then this hint will not be valid, because if I'm not looking for any specific values, I cannot use an index walking technique or index range scan to find those values. So therefore, this hint was unused. We were not honoring this hint because it's not the valid thing to do for this kind of a query. And we just ignored this hint because of that reason. It was not valid. And then the optimizer proceeded and did whatever it thought was best on this table. And apparently, based on the statistics and based on the nature of the query, the best thing to do was to use a fast full scan, right? So in other words, basically what this means and sort of shows you is that don't use, when you deal with indexing, don't use index hint. Either force the index range scan or index fast full scan, depending on what you actually want to achieve for your specific query. But don't use that, because this seems to be like a higher level blanket, not a blanket, but like a higher level umbrella hint. Like, hey, that use an index by any means you can. I mean, even if it's a stupid thing to do for performance, right? So, yeah. So hopefully this explained a bit of this. And hopefully this explains what I said here, that or where did I say that? Well, that even though the hint syntax was valid, then it couldn't be used for your kind of a query. The execution engine doesn't really support that, so the optimizer doesn't do that, right? So, and another example is another example of a similar case where when you look into hints individually, they all look good, but when you look at the bigger picture, then there is a problem. So there is a case of a conflicting hint. If you say, use a hash join for table 2 and use a nested loop for joining the same table. Well, which one is it then? Well, both of these hints will be conflicted, both of them will be ignored, right? So I could do this. So continuing the same, example. So you see, this rs ask gives me a fast full scan, right? No, sorry, what the heck? Sorry, it doesn't give me a fast full scan because I don't have a where clause. So where card IDs, well, let's just use I'm gonna say this. So let me just do it like this. Okay, I'm just inventing demos right, in my head right now. So you see, if I run this without any hints, what does the optimizer do if we leave optimizer the freedom to decide by itself? Okay, you see, we get an index range scan looking for specifically these values when optimizer decides by itself. Okay, now when I say index fast full scan on orders table, right, we get a fast full scan, our hint is honored. And now when I do index range scan, not ascending but descending, because we're kind of, let's see, maybe both of them work. Let's see how smart Oracle is. When I say index range scan descending, you see, an index range scan descending. So it's like we start from 0 and then we go downwards. That can be useful sometimes, when I have a order by card ID. Like well, I have a sum here, right? But if I do something like this, I don't have a sum. Oops. And I have an order by descending. Well, you see, I have an order by card ID descending, but since we are already walking the index in a descending manner from 0 to down to negative values, it's guaranteed that the rows will come in an order. So we don't even have a sort. We don't have a sort order by step here at all, because the rows are guaranteed to come in the right order. So you see, my hints are honored, right? But now let's do both. Let's use both at the same time on the same table alias, right? Actually, before I do that, I just finish this thought. So this is the index order. This is the descending. What if we do index ascending, but we still have an order by here? Okay. You see, that's actually interesting. You see, we said that, hey, let's do an ascending index range scan, but we have an order by descending, and we are actually using my hint here is not used. So let's see. Let's look into the hint section in Oracle 19. You see, my ascending hint was unused, probably because we had an order by here, right? And I could enable optimizer trace, and actually sometimes optimizer trace has more information, right? But if I remove the order by, you see, I removed the order by. Now we have an index range scan, which is an ascending index range scan. What the heck? Oh yeah, so sorry, I removed the order by, so that's, yeah. So this is an ascending index range scan. We start from the beginning, from the leftmost block of the index, and we walk all the way until we find 0, and then we stop, right? We walk upwards, right, in the value chain or in the ascending. So, and this hint was used, right? But in the previous example, my ascending hint was unused because I had an order by in there. You see, if I look into the index hint, index descending, right? So it was unused, and if you enable optimizer trace, you possibly will see something saying that, hey, we are ignoring it because we realized that you're using an order by anyway, and we will ignore your hint because you actually want to see data in a different order. So you see, it's not very, there are like things which may look like special cases and so on, right? Okay, and what I really wanted to demo was this, talking about hint conflicts. So we have an index hint which is honored, right? This is where this last example, this hint was honored, and previously I do index fast full scan. You see, I will add a conflicting hint on the same table. If that was in a different table, then it's fine, right? But I had add a conflicting hint on the same table alias, right? Here we go. So first of all, I said use a fast full scan and use a range scan, but these both hints, I mean, these hints are conflicting. I shouldn't have multiple hints trying to control the same thing concurrently. So these hints were unused, and you see in some cases Oracle prints out extra reasons as well. Why was it unused, right? And actually, this ended up, optimizer had the freedom to do what it wanted, and since we only wanted very small number of rows as estimated, we use an index range scan. But actually what I wanted to demo is, what about doing this? Let's, I don't know, let's use a full table scan let's use a full table scan and an index fast full scan on this table. Obviously these hints will be ignored because they are conflicting. Neither full or index fast full scan are forced. Optimizer has the freedom to do whatever it wants. You see, it ends up doing a third thing, like a range scan. Okay. Right. There's one question: how do you enable the optimizer trace? What level trace it is? Well, that's the, it's the optimizer 10053 trace, right? But I will not go in there right now because maybe in the end I want to go through my planned content, right? But the optimizer trace file is useful. And actually, in the end, I'm gonna show a bit of it to you anyway, because this section, hint report section, has shown up in Oracle 19, but there are some opportunities to see info about hints in the trace file in earlier versions as well, although it's not as thorough as you see here. Okay. All right, so I hope I showed you some conflicting hints. Another example of conflicting hints is it's interesting. You see, nested loop prefetching and nested loop batching, these are different features. But if you add, so I'm not gonna, you can Google for this what the prefetching and batching are. There are blog entries about it. Mohamed, if you have any pointers, then put them into Slack or into the chat here in GoToWebinar, right? So so that others can read these things. But there are people who have written blog entries about it. But these two features, they control a different aspect of a nested loop join. But if you add this hint and this hint against the same join, they will both be ignored because they are considered to be conflicting, even though they control different aspects of the nested loop join. But it's just how it works, that if they control them, well, I guess this is not a good example here, but if they control this, they will be conflicted basically, right? They shouldn't be because they control different aspects, but the hint infrastructure doesn't, I guess it doesn't know, right? And if you actually want to control both of these at the same time, for some reason, then there are undocumented parameters for that. I already have forgotten what is it, batching. I know NLGA batching, nested loop batching, and or again, I don't remember which parameter was the nested loop prefetching one, but anyway, so so this is a special case what I've found out, from experience. So hint conflicts. Okay, so I think these two will be more complex to explain. So I'm gonna sweep through these examples one more time. Actually, I have more things I want to show in the simpler scenario as well. So here is one example. This will be the most hard to explain probably, right? And I'm just thinking in which order should I go. Yeah, I think as this is the hardest, I will like leave a whole section for this. So there are cases where you add a hint which is okay and correct sort of in a narrow view locally, but but then the query transformer tries other things as well, other plan shapes or other query block shapes, right? And it finds a different query block shape transformed differently, which has a lower cost, but the lower cost transformed query, in this lower cost transformed query, your hint combination is not valid. In other transformed versions of your query, your hint combination is valid, but a transformed version has a lower cost. So I'll get back to that. So I wanna, this will go deep, but I'll just wanna sweep through this first. And so another case is that your expectations are incorrect. So here I forgot to enable or show that. You see, you might have an index, but it's not visible, right? That's also a case where your hint suddenly stopped working, right? And if your hint is called index, then if your index, a suitable index, is not visible, then the index hint will do something stupid. So index range scan, ascending, and so on, they're better to use nowadays. Okay, anyway, and expectations are incorrect. So, for example, parallel hint. Parallel hint does not force parallelism, right? And actually, this is an article by Jonathan Lewis, where he's explained it, and I've explained a similar thing, from a different angle. Like this is not really a hint, but when you say alter session force parallel query, even that doesn't force anything. A parallel hint and this command, what they do is that they will adjust optimizer costing accordingly, that those things that are parallelizable, like full label scans and even partition index range scans nowadays address different indexes or nested loops and so on, but those things that are parallelizable, they will be costed lower accordingly, according to whatever parallel degree do you have, right? So but if there is a plan with a better cost, then the better plan will be used. So let's do this. So select star from select let's say what should we do? This column invoice address ID, you see it can be nullable, right? So even if there are any indexes on it, it's not necessarily gonna be part of an index and so on. So anyway, so I'm just gonna do a count star where from I'm gonna use the big schema, SOE schema, which is the big one. So SOE orders where okay, you see? Well, I don't even have to do this. I'm just going to select this one row, right? So actually, let me do a count, so just to show you something. Okay. So so this is a primary key, right? Or actually, let me do this. That's going to be even better. Just I'm going to say where order ID is bigger than 1. You see, this is going to take a long time. This is a big table. And maybe, yeah, okay, so, well, I have very fast storage and so on. So, and let's see what plan we got. We had a full label scan. Okay. We have a full label scan and its cost is 275,000, right? And now I say, let's do a parallel. I'm going to use a parallel 16. And I tend to use statement level parallelism. There are again, you can also say, table alias and the degree, but to me it doesn't make sense to have like wildly different degrees for different tables on the same plan. I mean, I use statement level parallelism. This is a valid way to hint. It's like, hey, the whole plan is parallel 16 and so on. See, it was pretty fast. You see, and now we got a parallel plan, and so that I just complicated my situation here. We got a parallel plan, and the optimizer has found that, hey, since I'm sorry, I'm looking for a wrong thing. So I have a blog entry about this whole thing. So let me just. So this is what I used. I was not doing a lookup. Okay. All right. So you see, when I searched for almost all orders in my table, then in serial mode, the cost was 275,000, right? And when I run the same query, count this. I'm still counting this same filter. I ran the same query with parallel 16. Now the estimated cost has dropped to 19,000, right? So if I do a calc 19,000 times 16, well, it's 300,000. So there is a, it's not as simplistic as I showed, but the serial cost was 250,000. The parallel cost, parallel 16 will be costed to 19,000, right? So there is a bit of, Oracle acknowledges overhead. There is, I think it's like a 90% thing that if you use parallel 16, then you pretty much divide the cost of your full level scan by 16, but we expect only 90% efficiency. So we sort of add like 10-ish% that, hey, doing a parallel scan is not going to be as efficient as a serial scan, right? I don't remember the exact logic, but anyway, so you cannot divide it exactly like this, right? But now when I do select parallel, 32, right? You see, the cost has dropped from 19,000 to 9,000 because Oracle, that's what parallel costing does. It says that, hey, if you have 32 slaves scanning through this table, then we will get it close to 32 times faster. That the cost drops, right? And now the cost has dropped, and according to optimizer so now that we know that we can scan in parallel, the optimizer can adjust the parallel scanning cost and comes up with whatever plan is the best for this. And now let's do this. I'm changing only one thing. It's still parallel 32. We know that full table scan cost is 9,000, and I'm gonna do this. And looks like my demo is, let's see if my demo failed here. This is interesting. You see, I have a blog entry which explains that, this only, let's see, order. Let me just use equality. Let's see what happens here. Okay. Okay. So something with we gotta look into the lower than condition as well in a moment. But you see, when I use equality equals 1, it was really fast. And I said parallel 32, right? So let's see the plan. Okay. And because this is Oracle 19, we will actually get a crazy looking plan. And I will point you to your blog entry. Let me show you what would happen in, I think it was the change happened in Oracle 11. So let me just do this once more. So if I do this, if I query most of the rows, I correctly get a parallel full table scan. And now when I query only the single row, really, it's really, really fast. And when I look into the plan, it's serial. So you see, I have a parallel hint in here, but for some reason it's serial. You see? And this outline section says that, hey, we are using a index range scan ascending, and the parallel hint was actually unused. Why? Because look at the cost. As I said, parallel hint by design, parallel hint does not force parallel execution. And the alter session force parallel query also does not force anything despite the name. All that these things do, they will reduce the cost of parallel operations. When optimizer estimates, okay, we want to find only one row, and parallel 32 is allowed. If we did a full table scan, with parallel 32, then the cost would be 9,500 to scan through this table in parallel. But since we're looking for a specific value, we're actually, this column happens to be indexed, then if I used an index unique scan without any parallelism, the cost would be only 2 here, and total cost would be 3. So 3 is so much lower than 9,000. So therefore optimizer picks the best plan. So the parallel hint doesn't really force anything other than costing changes. But if you still find a better plan with a better cost, then then we go. I mean, we use the better plan, even if it's not parallel, right? So this is one example of where the expectations might be incorrect because of bad documentation, or you haven't read the documentation, or maybe somebody's blog entry has gotten it wrong, and so on. I mean, I get things wrong as well, so I'm not blaming others only. So it happens to everybody, right? So sometimes expectations are wrong, okay? And the hint was unused, and unfortunately, it's not always explained here why, right? There's one question: why is parallel not part of the outline hint? So it's actually a good question, and it's parallel is a kind of a different thing. So perhaps it's not a very, maybe it's not a very good way to explain like this, but I'm not sure if parallel index is part of that, but basically parallel hint is it's not really controlling your plan shape. So parallel hints are not stored in the outline, right? Because maybe you want to run parallel 4 one day and parallel 8 another day, and so on, right? And by the way, my personal preference is to not use parallel hints, and even not use parallel degrees at table level, but only this workload, because parallelism should be dependent on what workload you're running. Whose report is it? How fast does it need to complete? It shouldn't be a table level decision, right? So what I often do when I design systems like that, I don't have parallel degrees as well. I mean, every object is no parallel, right? And I don't use hints, but only these batch jobs or these workloads that need to use parallelism, they will use alter session, force parallel, query parallel, and then whatever. This can be done with a logon trigger, or another option is that you make all tables parallel, right? You enable parallelism for all tables, and then you control who gets how much by resource manager, right? Or you use parallel and in modern versions, of course, if you go parallel degree policy equals auto, then Oracle has, even if all tables are no parallel, then it can still decide to use parallelism, right? And then you control it with resource manager, for example. So that's kind of a little bit of a different topic, but yes, parallel hints are not part of the outline, right? So, and so if parallel hints are not forcing a parallel query like you see here, well, when would they be honored, right? Well, again, when you use let's say in this case they will be honored. Well, I mean, the parallel hint is honored anyway, right? And the parallel hint is honored in the sense that it will adjust the costing. So the fact, you see, parallel 32 had cost 9,500, right? So this is the query which actually queries all of the rows from the table. And parallel 16 cost was 19,000, not 9,000 or whatever it was, but 19,000, twice more, right? So that shows that this parallel hint is used, it is honored, but your expectations are incorrect. Parallel hints do not force parallelism, they adjust parallel cost. So it works. It works. They parallel, when optimizer estimates what would be the cost of doing a parallel full table scan, 19,000. What would be the cost of doing a parallel full table scan with parallel 32? 9,000. So the hint is honored. But in this case, we just happen to have, because we're looking for a very small amount of rows, parallel costing is honored. If you look in the optimizer trace, you will see it is honored. The cost will drop, but this index range scan has even a lower cost. So therefore, optimizer honors your parallel hint, but there is still a better plan, right? So that's what I say about expectation, right? So the parallel hint was used. And now when I do this again, the parallel hint is used, it's still used, but given that I'm looking for a much bigger percentage of the rows, then optimizer will use the parallel plan, right? And you remember, if I switched to Oracle 11 optimizer features enabled. If I go back to Oracle 19 or even Oracle 12, you see, I run the same thing with the equality. Let's see what the equality gives me. You see, in Oracle 12 upwards, where's my mouse? Oracle 12 upwards, Oracle comes up with some funky parallel plan where the bottom half is serial. This is a serial part done by the query coordinator. Query coordinator has basically queried my table, and now it distributes the row IDs, what it gets from the index, to parallel operations. See, this is parallel, right? This doesn't make sense because I'm looking for a single value, but imagine if you have 10,000 values, then query coordinator can read 10,000 row IDs from the index, distribute these to the individual parallel slaves by hashing of the block address where the row is in the table. So you have 32 slaves who all kind of read, the table rows from their set of blocks, from their area in the table, kind of. So this is a new mechanism, which is supposed to make this kind of, that we have a single index range scan or something here, and now we read the index in a serial mode, but all the thousands of row IDs that we get from this index, potentially, they will be read concurrently by many different parallel slaves. I'm not sure how much this helps. This is certainly a weird plan with all this batched table lookups nowadays and so on. Then maybe there is not that much value here. But if you want more, if that doesn't make sense, so I have a script, I have a blog entry called "Scripts for Drilling Down into Unknown Optimizer Changes" that optimizer has changed, right? And Mohammed, you have pasted a few links to go to webinar, but I see you have pasted them into organizers and panelists. You gotta select all attendees or entire audience when you paste them in. Please paste them in again when you have a chance. Okay. Anyway, so I have explained this situation here, and you see I have actually explained how the parallel resource cost, parallel cost of a scan, index fast full scan is going lower when you use a parallel hint and so on. And I will drill down into optimizer features enable level, and I will drill down into optimizer to optimizer fix level as well. So I'm not gonna go, I think, into fixes, but basically basically with this technique, I have a script which allows you to show which optimizer fixes, decision points or fixes have been enabled or disabled across different database versions, right? And actually, here is a fix: parallel table lookup accessed by row ID. So this is an optimizer enhancement which sort of has been enabled between Oracle 11.2 and 12.1, right? And that's what causes this funky plan, right? That's what causes this funky plan, even though, you know, we're fetching only one row and we get this funky plan. And you see, when I set this, I can disable this particular fix. You know, my optimizer features enable this 12.1. Let me go to all the way to 19. You see, but I have disabled this specific fix, right? Parallel table lookup accessed by row ID. And now I run this whole thing again. You see, now it's really fast. And this funky plan doesn't kick in even in Oracle 19 optimizer mode. You know, the rabbit hole gets really deep, right? So, you know, read that blog entry or attend my training starting next week, right? I had to mention that, of course, as well. Okay. All right. So I will, you know, one of the big to-do items is this, and Mohamed's blog entry actually explains one of these scenarios. I will show you a few more things. So let's go back to the index. Let's do this. And there was actually not fish. Well, if you want fish, if you don't know what fish does, then fish generates a fish, colored fish in your terminal. But anyway, so I didn't want fish. I wanted to find fix. Oh, come on. Where's the fix? Okay, let me take it from the blog again. Okay, fix control. Or actually not, we can actually turn this off. So what I just showed you, and we can so when I messed up my headers. I will just log out and then. So okay, so we have a fresh session. Okay, so I'll turn this fix off so the plans look a little more sensible. So because, you know, when I'm looking up for a single row, I would expect, I don't want the parallel query. You know, if I look up a single row with an index unique lookup, it doesn't make sense to run a parallel query, right? So, and you see that's correct, okay? And you also remember that when I take most of the rows from the table, you know, obviously now we get a parallel plan, parallel full table scan that looks like correct as well. But if I did instead of 1, if I do less than 1, let's see what less than 2 does. You know, I know the values. I know that this is primary key. That if I do equals 1 or I do less than 2, that should be the same thing. You know, I know my data, right? But for some reason it takes a long time. And this is very interesting, but I haven't thought about. So what's going on here? So we're getting a full table scan. For some reason, an index range scan in this case doesn't kick in. So let me run it once more, and let's do the X all, so it will show me the everything. So you see it says that, you know, the parallel hint was used in the sense, well, it was used, right? And it's interesting. So my question is, like, why isn't the optimizer smart enough here to you know, you know, because we estimate, you know, we know that we are going to get only 1 row, right? So why didn't the optimizer use an index here? Why didn't it do this? Because let me do this. If I do equals 1 it's really fast, and we get an index, and we do an I know that's a different. Yeah, I'm silly. So this will need a different hacking session, but I know what's going on, because if I do less than equals 1, it's slow again. It's a different reason. I'm gonna. The reason is I'm just gonna. You see, even if I try to force this, like even I can remove the parallel. So if I do index rs, I don't know, descending, you see it still doesn't do it's still slow. You see, and the reason is I just remembered. So it's not really systematic troubleshooting, but if I look into indexes, then you see the primary key index what I'm using is a reverse key index. This is because the order entry benchmark by Dominic Childs, you Google, it's a free tool if you haven't used it, SwingBench. It's a free tool that generates your schema, your data, and it can run a bunch of queries automatically as well. So it's really awesome. And in order to do, this is one way to improve index contention and concurrency when you do a lot of inserts at the same time. It's not the best way in the modern days, but that's what it uses. But the reverse key index cannot do range scans, so it's a different reason. So it's a whole, but it's also a valid thing to think about. You see, I just forced an index range scan, and let's see what this thing says. Let's see what the Oracle 19 hints say. You see, it says this index range scan hint is unused. Unfortunately, it doesn't tell us more reasons why, but it definitely was not used. And this is where you need to take your existing knowledge and examine, that this is the index what I would want to use. I wonder if it's a function-based index and I forgot to use a function in my query here, or I wonder if it's this or that. And when you look into the DDL of the index, you would see that, hey, this is a reverse key index, right? Reverse key indexes cannot do range scans, just like hash table lookups cannot do range scans. You need equality, right? So you could choose where order ID is in 1 or 2. That should be fast. Let me remove the hint as well. So that should be fast because I'm looking for multiple discrete values with equality, essentially, right? And that's what an in-list iterator is. You see, it will take this value and do an index unique scan for only this value, and then it will take the next value and it will do another index unique scan specifically for that next value. So it's going to be 2 index unique lookups with equality, and reverse key indexes do support it, right? So if I rebuild this index or create it again with a non-reverse, then I would probably get different behavior for my parallel query as well. But this was a really good example of another case of this, right? My hint syntax was correct, but my query, if I try to do a range scan on a reverse key index, it just doesn't physically work. It's not designed to work, and Oracle hasn't implemented anything like that. Therefore, the hint will not be used. It cannot be used. It's invalid, really, right? Okay. All right. So I'm gonna before I go to the next slide, which you may have seen a little, let's do this. So so I have a script called X9. You see, X9 does an explain plan. So it comes from the old days where people, when you had Oracle 10G and 11, but some people still used 9i. So where you had to use explain plan pretty much, right? So that's why it's called X9. So this works also on 9i and lower, right? So it takes whatever query you have in the buffer and it runs explain plan. You have to see that it actually explained it successfully, that there was no syntax error, because otherwise you would see the old previous explain plan in there. But anyway, so or or you run the query, you see it seems to work. It's kind of slow, and then you do x9, and this query is still in the buffer. You do x9, right? It doesn't explain plan. So Oracle correctly picks full label scan here because you want to get 71 million rows out of 71 million rows, likely. I probably have that many rows in the table. So Oracle does a correct thing to use a full label scan instead of trying to use an index for 99% of your rows. Okay, but what if I do this? Index rs ascending orders, I just do x9. Okay, you see, okay, that's interesting. So I did not expect that. Let's see what's wrong. What went wrong here? So it says index will be unused. Okay, I'm stupid again because this is a reverse key index. I'm a little stupid. So of course I should use a. Let me pick another one, which is like warehouse index. That's another reverse key. So so there is a warehouse ID column. Okay. So where, but I think the outcome should be the same. So that well, if I do x9, you see now it honors the hint, right? Sometimes when I just when I work and I have multiple hints and I want to like temporarily comment one out, I just make the syntax invalid, right? So let's see what will we get now. You see, when you make syntax invalid, then optimizer will decide on its own, and you see this. There is a syntax error. There is no such hint. It says syntax error here, right? And Oracle. So when Oracle cannot use the hint, it will, in this case, it will use a full label scan, because if you want 99% of the rows, then full label scan is probably the way to go. Or an index fast full scan if you have an index on all the columns you need to use, like this and that in the same index. Okay, so let me get back to this. So this works. You see, I'm gonna do okay, so this was successfully explained. If I use this hint, it works. Okay, let's do this. A. This is successfully explained, but the hint stopped working. B. Let's use B. This was successfully explained, but the hint is used, or Oracle decided to use an index range scan, and at the same time it says that there is a syntax error. But there is a syntax error for something called B. So what the heck is going on? So let's say C, right? Syntax errors for something called C, the index range scan is, but my hint, my index hint apparently is used. Let's use D. Now we get a full label scan. so let's use E. Come on, so let's use E. Full label scan. F. Now we get an index. So it all makes sense, right? Easy. So what's going on? Reserved words. I have a script called res which shows you reserved words, like I don't know, from. From is a reserved word. It comes from $, reserved words. Because I'm lazy, I don't read documentation. If I can query it from a $, view, you lead to if all else fails, then you go and read the documentation, right? But if I have a res too as well, I think if I want to search for just one character, I'm going to search for reserved words that are just one character. Okay, let's do order by as well, right? So I just added order by here. Okay, so these are all single character reserved words. A, D, E, G, blah 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 are reserved words. So that's why we have, you know, when I have A in the beginning, we have a one behavior, and when we have B in the beginning of the hint section here, we have a different behavior. You know, full level scan up here, but here we have an index range scan, and it's kind of says that, hey, there's some syntax error. Because that's because A is a reserved word, D, blah 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 are reserved words, but B is not, and there is a behavior difference. Number one, you know, or number one reason, or the, you know, the note what you would need to read is this, that an invalid hint that comes before other hints can cause following hints to be ignored. So for example, you know, like when I do this, obviously I mean, if I only have this hint, it's honored, right? If I say, let's see, I'm gonna say use NL, but it's an incorrect hint. I'm not actually, you know, I'm not actually specifying which table I joined you that should use a nested loop. Let's see what happens now. You see, well, actually we got lucky here. You know, use NL has a syntax error, and I don't know. Actually, this is it. You see, use NL had a syntax error, and everything after that was ignored. Because if we leave Oracle if we let optimizer to decide itself, it will use a full level scan because we want almost every row from the table. You see, this hint doesn't even show up here, neither used nor unused. So Oracle just hit the problem here and it stopped. So if you use an incorrect hint, then Oracle stops. If you have a syntax error, Oracle stops. It doesn't look further. So you see, if I put the use NL, the incorrect hint, into the end, you see, now the hint is honored. See, because we first get to this hint, honor that, and then we get this syntax error and we stop here, right? Or, you know, it kind of goes even, you know, more complex. You know, you go, I'm gonna say use NLL. Well, now my hint is used. I don't think the output is completely consistent here, but you see, my actual hint, what I wanted to use, is used, and whatever is here, this gets ignored because you see there is no such keyword. So Oracle is apparently smart enough, even though it doesn't show the hint here. It's smart enough, you know, because you see, if I look into reserved words, there is no such reserved word like use NLL, but there is a reserved word called use NL, right? Which happens to be a hint, right? So when I use complete garbage, which is not recognized as a hint or a reserved word, I can put these things into the beginning and other hints will get honored, although it doesn't even report that this hint was used. And similarly, when I use, you know, what is it, a keyword, this is not a hint. A is just a keyword, right? Or it's a reserved word. So now we get an index range scan. Interesting, it doesn't show that this hint was used, but well, let me see what happens if I remove this. yeah, I have X9A shows me more sections, so it doesn't show this, right? Interesting, it doesn't show it for some reason. I'm not. Reserved words, and even on 19, if you have a reserved word, you see here you go. So you know C and D. With C, my full table scan hint is honored. With D, it's not honored because D is a reserved word. You know, select. You know, this is floating point. D is double, right? These are the floating, the floating point data types. I have forgotten what A is, but when you think about what is G and M, these are gigabytes, and when you create data files and whatever, gigabytes and megabytes and terabytes and so on. So a lot of single characters are reserved words as well, right? So, so I just wanted to share that this may cause a lot of confusion. And real life example from past was that when back in Oracle 9i, no logging hint was a thing. You could actually insert somewhere and add a no logging hint to a query, to an insert append statement to get no logging behavior, but they removed it. So you see there is no such hint anymore in Oracle 10G onwards, because they disabled it. I guess because maybe developers made things faster by adding a no logging hint without really realizing the downsides, right? So logging or no logging should perhaps be like a schema level or the decision or a table level decision for direct loads, right? So this hint, so how do you put it? So now it's gone actually, but I think maybe in Oracle 10G it was still sort of recognized. Actually, yeah. So there is no hint anymore. It doesn't actually do what you want, but there is still a reserved keyword called no logging, because you can create, rebuild the indexes with no logging and stuff like that, right? And so it's still a keyword. And when you had a no logging hint first, and then you had all kinds of other hints, all the other hints were ignored, starting from Oracle 10G, because you hit a reserved word which wasn't really honored anymore, and it caused optimizer to stop searching for more hints here. Okay, so read this note. It may help you to reduce a lot of confusion. So, and this, again, it feeds to the same topic that, if you use hints, then you better be sure that you know what you're doing. Because if you just put random character, invalid hint syntax into the beginning, other hints may be unused. Or if you use just an index hint, like if you just use an index hint without actually specifying that, do you want like a fast full scan or skip scan, or do you want to do a specific like index range scan? That's when you may get in trouble, when you have this incomplete hinting and you leave some things to, you sort of force optimizer's hand, but it still can decide some other aspects, and you may end up with a totally bad plan as a result. Let's see if I created a few demos as well, so let's see what happens here. So this is some, like you have an ordered, there is an ordered hint, right? If you look into documentation, I'm not going to look it up, but let's say, so if I do select count star from DBA, not DBA, so let's see what kind of assumptions we will have here. So this is a two table join. I just want to join all orders of all customers, and let's see what happens, right? So we're going to get a two table join, right? I don't want to complicate. I want to complicate this, so I'm going to just do a no parallel. and actually, before I go there, it's like, okay, why do we get parallelism? So if I look into a table, you know, all tables in this schema are parallel degree 1. Parallel degree policy is manual, right? So parallel degree doesn't automatically kick in, right? But did I select, let me look into $V session, and it's a white table, so I'm gonna print the output. So parallel query status is enabled. I don't remember if I forced. I'm just gonna log out and in. So because somewhere I used the force parallel query statement. Maybe it was this session and I forgot to change that. So anyway, so let me just make sure. Let's try this one more time. So I still have a parallel plan, right? So what's going on? So this is when you look into indexes. Sorry. You see these indexes. These indexes have parallel degree 8 because they were rebuilt or built at some point of time, right? And I forgot to set them to serial. You know, this is what in an OLTP system where you know, that may, you know, bite you in the butt basically when you rebuild indexes or create indexes in parallel and then forget to set them to no parallel again, right? So I think, let me just see. Okay, so I have a script called, you know, I used it more in the Exadata times. So alter all indexes degree. Does it takes a table owner. Yeah, it takes the schema as an argument, right? So, and no parallel. Okay, so SOE, no. Okay, and SOE small. Okay, now I should have altered all the indexes to be no parallel. Yep. All right, so now life is a little simpler again. I don't have to use no parallel hints and so on. Okay, so let's see what happens. So first of all, since I'm using a count star, I don't actually want to see any values. We don't have to go to the table at all. Apparently, we do a hash join on results of this index scan. So again, remember, this is like a full table scan on the index segment. And you see, when you look into that line 3 and 4, what columns are we taking from this? We're taking only the order ID and the order ID from these indexes. So there is no reason to go to the table at all, right? So we are actually doing a hash join on the results of the index scans, right? And but let me just do then. Let me just do, I don't know, some I'm just okay, so I'm just gonna look into some values actually as well. I'm just gonna do a select sum order total, you know, from the orders table, and let's take, I don't know, average, or let's take maximum, you know, the individual unit price or something from an actual order items table. Okay. All right. So, okay, now I have to recall what I was going to demo. I think I wanted to show you the like unnesting as well. So I'll start from this manual because I'm here. I'm starting from the manual one. So I'm gonna say I will add. So this is the join condition here, right? But I will add one more thing. So and show me only those. Don't take everything from the order items table. The order items table is the bigger table, right? So you see, orders table has 1.4 million rows in this small schema, and 4 million rows in the big, and order items has 4 million rows, right? So, and you know, when you do a hash join, typically it makes sense to have the smaller data set as the driving part, because you know, hash joins have to fully cache, you know, in PGA or temp, at least the driving table, right? So the leading table in the join, or the left side table in the join, right? So it makes sense to use the smaller data set, right? Whichever table returns less rows and, you know, bytes essentially, so that there would be less PGA usage, and the hash table we have to build would be smaller, right? So this looks like a correct join order, right? And but now I'm going to change the query. I'm going to say take all rows from the orders table and take only some rows. Take only some rows from the order items table. The order items table is the bigger table, but thanks to this filter, you know, which we will push down to the table level, we will return less rows, right? Okay. And you see, we are starting from the bigger table. So we are starting from the bigger table, but since this bigger table has a filter on it, not a join condition only, but actually has like a full specific filter, then this bigger table actually is not going to return that many rows. So this optimizer estimates that we get 300,000 rows out of 4 million, but you know, I think we get even less, right? If I added a count star here, right? So we don't necessarily have to start from the bigger table. Sorry, we don't necessarily have to start from the smaller table, but we have to start from the smaller row source. You know, whichever table returns less rows, less bytes, you know, after any filtering that is done straight on this table level. You see, the orders table doesn't have like a regular filter. It doesn't have a specific value you look for. It only has a join condition. So it actually makes sense to do this in this order right now. And now let's say that I've read from somewhere that the smaller table always must come first. I know that the orders table is smaller, so I'm gonna say ordered. You know, I'm gonna use an ordered hint here. And when you have an ordered hint, then whatever your query text after transformations is, this is, you know, that this table comes first. So therefore this table will be first in the join order. You see, here we have, it actually is honored in this case. Okay. So, but let's see which way I want to do this. I may need to I want to show that I don't use ordered hint. There's a better hint called leading. Let's see what when you use leading, if I say that use a table O as leading one, or alias O, right? I have to use aliases for them to be correct, you know, because I have defined aliases here. You see, okay, it's also honored. So I'm gonna show you this a bit more complex example, which is, I guess I did something wrong in my demo. So here is a script, and I'm going to disable adaptive plans just for simplicity, because otherwise there are too many moving parts. Although adaptive plans don't change join order, they only can kind of delay deciding the join method a bit. Not the join order, but join method. But anyway, I'm going to disable that, so it will be a bit less noise on the screen. And I'm going to run so you see, okay, yeah, so this is a 3-table join with customers, orders, order items, you know, and we are filtering by the quantity that on the only actual direct filter that we have is on the order items, is on the biggest table. The other two tables don't have any filters at all. They only have join conditions, right? And that's why, by the way, when I write SQL, I often, when I know if the SQL is going to be complex enough, I do this. I actually, either you use ANSI join syntax, because ANSI join syntax sort of separates the join clauses from the filter clauses, but when I try to understand or write Oracle SQL, then you see I've separated. So these are join conditions. These are the actual filters, right? Joins cannot like filter in the sense that they only can take rows from this side and that side and throw away with what didn't match. When we deal with hash joins and then merge joins. Nested loop joins are a little smarter than that, but hash joins are pretty brute force. Anyway, so let's run this guy. So we have customers, orders, and order items, right? And you see, the order items is the biggest table, but for some reason we start from the biggest table. And again, the reason is the same. Look here, number 4. So we have a filter. So we actually, even though we have a lot of rows in this table, so this is the bigger schema. That's we have 200 million rows. 200 million rows in this bigger schema of orders, order entry benchmark. And so that even though this is the biggest table out of the 3, since we filter for that, optimizer can derive that, hey, we expect to only get 19 million rows. And I don't know how many columns we get. So that's, you see, the other tables would return more rows, right? So it makes sense to start from this. So even though that's the biggest table, we get the smallest amount of rows from it. Okay, so optimizer did the right thing. But let's say that I want to try to be smart here. I'm going to say, hey, I'm going to use, let's use leading here. I'm going to use leading. I know my data. I want to start from the customers table. I want to start from the customers table, and then I want to go to, let's see what happens here. So, I just added the hint here, so that's you see, I have a leading hint here, but you see this, if you walk through the execution plan tree and go to the first leaf without children, this is the basic way how you find where the execution starts from, even though there are exceptions. Then we're still using order items. So let's run this thing one more time, and let's use, I have this X9 all, which shows me, like the all sections. I guess previously when I used just X9, I forgot to use this perhaps, or perhaps this section, if I'm not explicitly showing the hint report. You see, when I show this, you see, okay, that's the advanced output. But if you look into, you see, in Oracle 19, you see, you can also say plus hint report. But I guess the advanced section also shows it, advanced mode. And also perhaps, I've already forgotten about it, but perhaps when there are no errors reported, then Oracle doesn't show this section. But when there are errors reported, then Oracle shows it automatically. I think that's why we sometimes saw it, sometimes didn't. But anyway, you see, there are no errors reported. Our leading hint was honored. So if our leading hint on the customers table was honored, how come the orders table is still there? Well, here's another thing. There's something called swap join inputs. So there is an I haven't even mentioned it here. So there are other examples as well, but there is another example. This is another example of incorrect expectations, or sort of too limited expectations. or sorry, limited knowledge and incorrect expectations. Oracle nowadays can physically swap hash join contents around. So I'll try to say this in a short way. So when you use a hint like this will force the logical join order. And when you use, especially when you use outer joins and so on, in some cases the logical join order has to be a specific way, because outer joins, like inner joins, regular joins, they can just be joined in any direction, A to B or B to A. But when you have an outer join, then logically this can go only one way. You have to get all rows from one table, even if there is no match, right? You have to get all the rows, which come from one row source, after any filtering, and then you find matching rows, if any, from the other table, right? And when there are no matching rows, you still show the first table rows because it's an outer table. So logically, outer tables restrict what kind of join orders can be used. But physically, hash joins can physically still, even though the logical join order has to be in some order because of relational algebra, requirements, then sometimes, if optimizer wants to, it can physically still do the hash table lookup and scanning in a different order. So if I look into swap join inputs, hint, if I really wanted to control this, like, hey, it's like, hey, I mean, this is wrong. I mean, I know I will get a better performance if I have the proper join order. So you see, swap join inputs has an inverse, no swap join inputs. If you really want to force that, then take this hint and go to your query, paste it in and use no swap join inputs here, right? I'm not saying that this is a good way to do things, because there are still so many other things what optimizer may, what I'm not locking down, but that if you are experimenting, like, hey, this doesn't make sense, but let's see if my query actually is faster, when I disable the physical join order messing around, for the optimizer as well. So let me I'm not even going to run it because I don't know if it's actually going to be faster or not. You see, now I disabled the physical join order replacement as well. And indeed, my customers table is the first table where everything starts from, right? And since I have not locked down the other tables, then optimizer still has the ability to, use whatever join order is for the remaining tables. But also, it kind of matters what join conditions you have, because optimizer can evaluate Cartesian joins as well in the middle of the plan somewhere. But if you have a lot of rows coming from both tables, both sides, then Cartesian join is not a good idea. So because we, logically, because of these conditions, we have to go from, customers to orders or vice versa, and then from orders to order items or vice versa. I could do something stupid. I could say, hey, start from customers and then go to order items, and there's like one missing link in between. Let's see what happens here, right? You see, optimizer honors that. If I wanted to start from customers table and can then go straight to order items, well, because there is no relationship, there is no where clause between those tables, then it has no choice but to do a Cartesian join, and you will get a quadrillion rows, right? A billion trillion rows, it's going to be a quadrillion rows. And then you will take this quadrillion rows and you will join it here. You probably don't want to do that, right? So, but not in this order, right? But, if you want to do kind of more concrete or complete hinting, you just say this. Start from table C, start from customers, and then join orders to it, right? And I don't even have to specify this anymore, because that's the only table left, right? So there is no more tables, so I don't really have to, specify the last one. But if I really want to, I can just also say that, right? I think the syntax should work without the commas as well. I think it should go for it. So let me do that. I'm gonna use, yeah, actually I already showed it to you, right? So with a comma, so it worked, right? With commas, so okay. All right. So this so what is to be said here is that if I go back to the original example, you know, and I run this query, and it doesn't seem to be doing what I want to, because you see that it doesn't start from this table, then often people want to jump into optimizer trace files immediately and advanced things like that. Actually, you don't need to do that, because the first thing you want to know is look into the outline section, right? Look into this section, because this will give you sort of hints. Literally it will give you hints, but also like it will hint show you some ideas. What kind of things was it doing, especially when it was doing transformations and so on, right? And what you would see here is that swap join inputs has shown up, right? So my leading hint was honored, but I did not lock down everything for the optimizer. I still gave optimizer free hands to do other optimizations, and one of these other optimizations, swap join inputs, ended up changing the plan, right? So my knowledge was incomplete about what I wanted to do. So this is a feature of hash joins, but other joins don't have that swapping functionality. All right, so I think I'll show you a couple of more demos. I'll finish in like half an hour. I'll do 16 more minutes. I don't want to run over time too much, and I'll have a sip of coffee first. All right, so we already talked about this. Where can you put hints, because you got to do that right as well. If you want to like null, it's just like empty here, but if you want to sort of not unnest this query and convert it into some semi-join, then you would have to add the no unnest hint right into the query block itself, right? That's one option, right? So because if you add no unnest here in this vanilla form, then there's no unnesting in the parent query block, so it only applies to the subquery or this inline view, merge, and no merge apply to inline views, but only to these specific inline views or subqueries which you want to control. But you can also add hints in the parent query as well. Like if you want to control this subquery, one option is that you will name this subquery to something like my inner query or whatever, and then you can put all your hints into the top level. You'll say no unnest, but you will address this hint to this subquery because you've named it. So this is how you can do this kind of hinting. You can have all your hints in the main query. And if you think about it, if you look into here, like all these outline hints, what the stored outline would use, or what a SQL plan baseline would use, all these hints are these global ones, you see, in the sense that these hints are not somehow put into the query text into the subquery. These hints are applied generally, applied on the whole entire query. And these addressing, you see, select query block 1, this addressing determines that which query block will use it. And I have this example here. I have like a select something from customers, but only show those customers where this complex filter condition is true. I don't actually want to show anything from orders or order items or other items. I want to filter the customers table based on the result of this query. And since you see this orders and blah blah blah, they actually this customer ID in the orders table points to customer ID up here in the main query block. this makes it a correlated subquery. So this here is a whole correlated subquery. So it's multiple query blocks, right? This is one query block, this is one query block, and this whole main query is another query block, right? So, and let's see what there are a few things that could be demoed here. So it was explained, no syntax errors. Actually, let me run it. Let's see what happens. So it looks like Oracle has, from the plan. Let me see the hash value is this. I'm gonna use explain this SQL ID and advanced. It shows everything. This SQL ID, this is the child cursor. I'm gonna do it because I'm gonna show you another script called of mine, XBI, explain better by SQL ID extended. This is wide output. It's very wide. So I'll show you in a moment. This is all in GitHub, right? So I'll start from this. So first of all, you see, Oracle has, if I look into this outline data to understand what Oracle was doing, you see, it has unnested my one query block here, right? And it has merged an inline view. You see, this is an inline view, you see, because we are actually selecting rows from this view, inline view, and we will pass it back to the parent query. But this here is this whole thing is a subquery that can be unnested or not, because we're actually not returning columns from here back to the main query and back to the user. We're only using this subquery for filtering what rows get returned back to the customer, to the user, but we only take values from this customer's table, right? So we don't actually return any values from this subquery here, right? So that's what, so this subquery was apparently unnested. Thanks to the unnest hint you see here, it was unnested, and we have a semi-join. It was unnested and converted into a semi-join. And the merge here is that, hey, there used to be a query block select number 3, and that query block was merged with its parent into select number 2. You see, when you do numbering, this is select number 1, this is select number 2, this is select number 3. Like there is when the parser finds what query blocks we have. And this is why actually, if you want to build or tune or adjust complex queries, you may want to use the QB name hint. You see, I have it on a slide and I'll upload it as well. You see, you can say QB name. You can give names to your own queries. I'll just say main query, right? And this guy is a QB name. This is my subquery. Like let's say order subquery, and this is maybe I should close the comment as well. And this is like I can actually put like some human meanings for here. So name. Let's call it the big orders. This is a inline view which finds big orders, right? Because any order where the quantity was bigger than 10, right? So and now when I run this thing, you see that the output gets more interesting. So for example, view merging. You see, we merged. There is some sort of an inline view called big orders, and we merged it into order subquery. This syntax here is, by the way, it's new in Oracle 18 or maybe 12.2. I'm not fully sure, but it showed up. In the older versions, it's just merge, and it doesn't tell you where it was merged, right? But this is like we took big orders and we merged it with the order subquery. So we took big orders and we merged it with the parent query. If I added like no merge here, this would mean that it would not get merged. You know, if I somehow for some reason want to keep it separate, right? And also, where else? Unnest. So that's actually gets a bit more complex now. That what is this? Because you know, when you merge a query with this name, query block with this name, and you merge it with the query block with that name, right? So when you merge these both, then what is going to be the new name of the query block? It doesn't keep the original names around. The new query block name will be basically, it's like I think these names are hashed together. Basically, this is like a hash value of the old query block names or something like that. So and now this query block, which was created as a result, got unnested. You know, unnested. So this whole thing, which was already transformed, it got now unnested into a hash semi-join, right? So having these names can pay off. It's cool. It's useful. So, and let me actually run this query. So apparently, that's actually cool. So I hadn't thought about that. You see, in the hint section, if you're wondering, like, I know that's something else. So it's the final query block. Okay, so I don't think I have anything useful to say here. So, okay, I ran this again. So the hash value of this query, or the SQL ID and hash, are these. And now I'm going to show my explain better by SQL ID extended and wide version. So, you know, this is not a very big plan, but this has a lot of extra info if your plan stats gathering is enabled and so on. So, but I just want to show you this part. So that you know, this would show, well, the original query block names are gone, unfortunately, but you would see that which line, you know, is what, right? I'm not sure how useful this is here, but you'll know that from which query block, into which query block different items belong to, right? And this is a lot longer topic that sometimes when I want to understand where do these query blocks really come from and go, you know, optimize a trace file is something that can answer that question, but it's very hard. Attend our virtual conference in September where Mauro Pagano would explain you something like that. But something what I sometimes do before, you know, I dive into trace files and so on is sometimes you can use a no query transformation hint, which will make your performance bad if it's a complex query. You know, but if you just want to understand that structure a bit better, you just say, hey, don't do any merging, don't do any unnesting, don't do anything like that. And now when I run this query, you see, if I disable all the transformations, like you see, instead of doing a semi-join, we have a filter operation here, and apparently there is one more semi-join here. So, well, let's just see what's going on here. So. Well, anyway, so this is what you get, and what you see now you have these lines here and all the query block names. You can actually see which query block name belongs to what. You know, which line is which query block. You know, for a small query it doesn't really matter that much, but when it's a big and complex query, queries, views, querying views, the query views, and so on, that sometimes helps to to visualize this in your mind a bit better. But when you run something in production, when you run performance, you have to keep the transformations enabled, because otherwise you will lose performance and optimization opportunities, right? You see, it's actually running much longer now, for much longer than it was previously, because the transformations are not helping you anymore, right? But I just ran it to see that. I just wanted to get a plan. Let's see, this like looks really nice. You'll see exactly that this table comes from main query. This whole thing is a semi, apparently it's the order subquery, and this is the big orders. This view here, inline view, is the big orders thing, you know, and you see all the filters here as well. So when your plan is like 300 lines, then this kind of things can help you kind of absorb or understand it a bit better. Okay, so yeah, so there are a lot of things that I was gonna say, but I haven't gotten there yet. By the way, when you use names like this, make sure that they are not more than 20 characters. Randolph Geist I realized that there's a bug, pretty much. It's a bug or behavior where if it's more than 20 characters, then these will be ignored. So let's see now. I'm gonna say order subquery. Let's test this, right? Okay, I'm gonna run this. You see, I have main query, I have big orders, and instead of order subquery, I have the auto-generated select query block number 1, and it's silently ignored. And let's see if the hint section says something. Well, actually, you see, hinted query block name is too long. So, you know, some things are, this query block name was ignored because hinted query block name is too long, right? So now it's not that silent anymore, but it was basically this silently ignored. But in Oracle 19, you will, you know, get some help at least. Okay. All right, so I already talked about this. That can be helpful. There was one question that how would you, is it possible to hint tables, you know, if you cannot really change like through view text and so on, right? I don't use that. It's a little cumbersome to use, and nowadays you can just create a stored, you know, use a baseline and change one hint in the baseline if you need to. But there is something called global hinting in Oracle. It's been around for a long time, and you know, you could say that, hey, you see there is a view called high pay departments, and you say that use hash join when you join the first table to the table D, table alias D under this view called HPD. So you can do global hints. You can hint through views as well, but I didn't really use it. So it's because nowadays, you know, the right way to hint really is, well, you have to do full hinting. I think I'll talk about it in a moment. I'll wrap up in a few minutes, and we'll look into a few questions as well. So I already talked about this. I'll have a view. I'll say a few words about full hinting in a moment. But so basically, 19C is awesome. It can, if you look into other XML, that's where the info comes from. This is what I used. It tells you some reasons why hints are not used, and you see there's an Oracle let me see if I can copy this. Oh no. I'll paste these links into chat if Mohammed hasn't done it already, but so okay. So you know, so Oracle 19 has this hint reporting like you've seen, and you know, one of the things what you could do that, like, I mean, that if you are running in Oracle 12 or even 11 or something like that, and when it misbehaves and you're not able to figure it out, well, you could export your schema and stats to an Oracle 19 development database, right? And maybe set Oracle features, optimizer features enabled back to Oracle 11 or 12 or whatever version you come from, and run your explain plan, you know, statement on Oracle 19 on the same schema, same stats, and same parameters roughly, right? So, you know, it might not always work because 19 is different. Even if you set the optimizer features enable back, it is different. But if you are not, it's better than nothing. You know, you can, if you cannot upgrade your production system to 19 immediately, you can at least use the same schema, same SQL in a development environment, and hopefully get some info about hints, right? Right. So, and you see here is an example of I'm using index and full at the same time. but my hint is unused. And you see some hints will tell you the reason. Hint conflict with another sibling, with another hint in the same query block, pretty much, right? So, yeah. And here is, you know, what they kind of mean. And when there is no letter in the beginning, then it means that the hint was used, right? Like here. Okay. And well, Oracle is a C program. You know, I just ran strings on Oracle and searched for, you know, you search for one of the strings that gets printed out. And if you get lucky, then all the strings are in the same location in the binary. Not always, not for every feature you look for, but in this case, they apparently come from the same module that got compiled and linked into Oracle binary. And the strings are all next to each other, right? And basically you'll see all the reasons in this version of all the printed reasons. You know, sometimes the reason is null and they haven't explained it further like we saw, right? But, you know, there are other, like duplicate hints, conflicting optimizer mode. You see, if you use optimizer mode is first rows and optimizer mode is all rows or choose at the same time, you know, then there is a conflict, right? If you say no hash join, sorry, no use hash, no use merge, no use NL, you know, you exclude all join methods, you know, well, we got a join table somehow. So I'm trying to do something invalid, right? Oops. So basically, you know, so this is a good way to learn about Oracle as well, that hint cannot be honored. I don't know what that is, but again, it cannot be honored because some sanity check failed, right? Hinted query block name is too long. That's what we just saw, right? Or you use hint with incorrect syntax, right? Or some hints are only valid for dynamic sampling queries and so on. So that's pretty cool. So, you know, you'll learn about Oracle's capabilities and limitations that way. Okay. So, and you know, these reasons, even though this is from 19C, these reasons mostly apply to older Oracle versions as well. Just older Oracle versions didn't just have this logic in it to explain these reasons to us humans. Okay. And what would you do before Oracle 19C? So I would recommend that you have a 19C database, take your application schema. You don't even have to copy data, only export the schema and stats from production and use that, right? With optimizer features enabled with a lower value, right? And if it tells you why it's not using a hint, then you pretty much got it, right? But if you don't have that ability for some reason, then you can get limited info from the optimizer trace file as well. You enable optimizer trace, you make sure that you hard parse the query so that the optimizer actually kicks in, and in the end of the trace file you will get this, right? But this is limited, this is very limited. So you know, when you have a syntax error, then when you have some sort of a syntax error and so on, you should see error here. And when you have resolved this zero, that means that hint was correct, but whatever table alias I used, that wasn't, we couldn't find it. You know, the table was called orders. I was talking about table alias O. We couldn't resolve this O to an actual table, so that will be zero, right? And what's tricky here is that whether something is used or not. This is not the same thing what 19C tells you. 19C has a pretty deep understanding of whether a hint was actually used somewhere deep in the optimizer path or not. This kind of, so this is a fairly shallow way of saying whether a hint was used or not. You know, let's see how you put it. So again, it's like that if you understand the hint and if it's like correct, but you know, it's almost like a parallel hint. You know, you use the parallel hint, it gets used, but you might not necessarily get a parallel plan. But that's because of incorrect expectations. Another example is that you force a hash join, but join elimination kicks in, and we actually don't have a join at all. So then a hint is still kind of used, as far as I know, but it will not. It's used. It's shown as used here because it was not incorrect. But later on, when transformations eliminated the whole join, then then actually this hint was not valid anymore. So and this 19C would tell you about it, but this feature would not tell it. It's quite shallow, right? And here's an example where I used nested loop batching and prefetch on the same table at the same time, and it says that, hey, when we looked into this hint, it was all valid. It shows used equals 1. And when we looked into this hint, it conflicted. It shows used 0. But actually, I think both of them really, when you look deeper, both of them were not used. So this trace file is a bit shallow. But if but it gives you half of what the 19C tells you, right? So sometimes hint is shown as used here in this shallow trace, which happens pretty early in the plan, or pretty I'm not, well, it's shallow. I can say about early or late, but it's shallow. But sometimes changes in the bigger picture, like query transformations, make this thing obsolete and they're not actually used, right? So I think if I look into, let's go all the way to, well, I don't even have Scott schema here, so, but let me go to a different database. I think I gotta be in the same, let me see. I think I have a foreign key. Let's say DDL SOE orders. Let's see if we should have a foreign key in place there anyway. So I have a foreign key script as well, but I forgot what the name is. Actually, help FK. Nope. I think I have it, but maybe it's not documented. So, but DDL uses DBMS metadata, and orders points to customers, and it's enable, no validate, and so on. All right. So let's do select count star. Let's so select. Let's see. Oh, I'm over time, but I'm over my overtime already, right? But I'm having too much fun. So who doesn't like it and is somehow stuck to the screen, then sorry, right? But who are still here, thank you. We still have more than 100 people logged in, so that's good. So so select, let's say, do we have a customer class? From SOE orders, SOE customers. Let's see how smart optimizer is. Let's do a select distinct customer class from SOE customers. See, SOE orders O, where C cus. All right. Okay, so this is when you use X9, watch out for this. You see I have a syntax error here, and my explain plan actually failed with an error, and my script just shows you whatever is in the plan table. It shows me the previous plan. So in order, this needs to actually be correct SQL. So select C customer class. Okay, so now it looks like it's correct, and I'm gonna do an X9. So you see now it's correctly explained, and we have a two table join. Let's see. I want to demo join elimination, and let me see if I had a bit slow. I'm doing something wrong. I have a join elimination script somewhere. Maybe Oracle is not too smart here. Let me just select this customer class itself, and I'll just do a X9. This is still the orders index and orders table. It still does a two table join. So Do we have Scott schema? Nope. I'm gonna let's see. I gotta take a look at the constraints. No. Or did I disable query transformations? I gotta, no, that's all good. I just do owner equals so let's see. So that, I mean, yeah, I'm stupid. I'm doing it the wrong way around. Thanks, Vishal. Yeah. I'm slow. You know, that's when you do run. So this, you know, that this is the parent table, and this is the child table. The child table points to the parent with a foreign key, and you know, hopefully the foreign key is enabled and validated. But I was looking at the wrong way around. So let's see how many orders. Let's do some order amount. Was it? Okay, sorry, wrong. Describe. I'm just gonna do, let's say some, what is it, order total, right? So from orders table and you know, customers as well, so that I want to like ensure that, you know, show me the total amount of orders which belong to some customers and they are not somehow like null, right? And I wonder if this has it still failed. We have the orders table. Now we went to customers table. I wonder if my if this foreign key allows, let's see what the null ability is. So if I look into this, so we orders, it's not null, so it should work. I have a brain fart. So anyway, so let me make it easy. I'm just gonna say that if you have a valid, you see here, I'm like, I want to go through. Actually, let me just see. This shouldn't matter because Oracle resolves column names. And one more thing, what I can do is there is a hint called eliminate join, right? So it's gonna be relatively easy for me to say that it should work this way. That if I want to eliminate the join to I think it's this way. I don't even remember which way. Documentation helps, right? That if I you know, I definitely want to see data from this table, but I'm not actually selecting anything from the customers table, right? So let's see what the hint section is gone. If I do this, oh, I don't remember which syntax I had to use, but now the hint section is completely gone. I'm not sure what I'm doing wrong. Anyway, so I won't waste your time with this. So there are plenty of articles about if you search for eliminate join hint, and there are plenty of articles which talk about that. Sometimes they're very useful. And there is also this. I have a that's actually interesting. Let's see what happens here. Wow, we actually just found something new, did we? Let me make sure that I'm not. So I had, when I was, that's a different thing again, but it's, you see, I sort of had two endings for this comment section. I think this will actually hide the output. Let me just do it like step by step. So I'm just gonna say this. So I just add a new line, explain plan 4 into the beginning, or insert new line. So, okay, so I'm stupid, yeah. So my X9 all doesn't actually, it actually hides terminal output when it runs that. So you see, that's why I kind of warned you that when you do this, when you use X9, then the other option is that you just run it, right? You just run it, and once it finishes or once you cancel it, now you can just do XO, show me the last query. So eliminate join is unused, possibly because I was using it, the second run was with wrong syntax. So let's run it once more. So, okay, so eliminate join is here is also unused, right? And you know, again, it's probably because I gotta check my you know, constraint states, and maybe I'm doing something silly here. Sometimes I have a brain fart like that. But of course, that if I try to force an join elimination, but if it's not a valid thing to do because my foreign key constraint is, you know, it's not enabled or it's not validated and stuff like that, and or and things like that, then if it's not relational, if relational algebra wise it's not the correct thing to do, from data correctness wise it's not the right thing to do, then of course the hint will not be honored, because I cannot force Oracle to do something wrong, right? So anyway, I'm not going to waste your time with that. So let's, not everything has to work in a hacking session. Okay. Yeah, and I think we can you know, finish. I'll maybe look into a couple of questions as well. So so you know, like I wanted to talk about why your hint is invalid, but I will leave a couple of slides in the end when I upload that as well. That, you know, when you actually really want to force a known good plan, then you have to fix so many different things of a query. You cannot just throw in an index hint and hope that everything else will fall in place. You know, because nowadays with modern version, if an optimizer if the optimizer does a really wrong thing, then it's often something about row count estimation, or stats are not right, or stats are not used correctly, or, you know, there is something wrong. There's something fundamentally wrong with optimizer inputs. Now, if you only fix one index, you force optimizer to use this one index, but everything else is off. Everything else is wrong because optimizer heavily underestimates the number of rows. Then forcing this one index and leaving all the other 99 things, you know, wildly open, where optimizer will make decisions based on bad stats, you know, that could make things even worse. Or if it doesn't make things worse today, then 2 weeks from now or 2 months from now, when something else changes, then it goes bad. So if you really want to force a plan to do exactly what you want, you have to worry about query block layout, that, you know, are what transformations. You know, if you have a 7-table join, then you have to force the join order, and worry about swap join inputs like we discussed, right? And think about join methods and access paths and so on. And you know, there is more. So it's actually, in practice, it's pretty much unrealistic that you take a 300-line query and, you know, manually craft all the hints. What is more realistic in these cases is that you run the query, and, you know, perhaps you know that, I know that the good join order is this. You manually hint the join order with the leading hint, then you run the whole query again. And if now with your manual change, or even if it's an index or a join method change, and if you run it manually and it works, that's when you take the entire outline of this good plan what you just achieved and you fix this entire outline, right? Because what you see in this outline, this is full hinting. This is what stored outlines used. Nowadays you don't use them, right? This is what SQL plan baselines use. SQL's plan baselines are basically a bunch of stored hints taken from outline, plus some extra magic, you know, extra, you know, validation of performance and and there is extra magic, but essentially how a SQL outline comes up with the known good plan, it's these hints you see on the screen here, right? So if you want to play with plans and you know that there's a pattern join order, you can add such a hint into your query, in your sandbox, or even in production if you're happy to run your select statements like that, or run explain plan at least. And when you get a good plan, then you take all the hints of the good plan, not only this one, and you fix this whole plan, right? Of course, there are exceptions, when your query is simple enough, or it's one query block you want to control, that you should not unnest that for some reason and so on. And there are valid reasons to only add a couple of hints, but these are usually about controlling whether some transformation happens or not, less about just saying that I don't know, use one index and the end of story. And I have scripts, like let's see if I recall. You see, let's say that if I want to force this for some reason, index range scan descending. Let's say that I have, well, let me do it like that. So let's say that I don't like the index unique scan. Do I have a better example here? Yeah, I'm not going to do complex stuff because we're almost done. So let's say that I don't like the index unique scan, but I cannot change the code of this query, right? This is production system, but I want to force this thing to do something else, right? So what I can do is that I can open a new session. I can add whatever hints I want to, right? Let's say that for some reason I want to use the descending range scan. And I will run whatever hints I need to add or think I need to add. I will run the query and verify, does it actually run faster? And if yes, then I will look into what are all the hints in here, right? And then I would need, if I really want to hint, I would have to ensure that all these hints are used, right? And I probably don't want to start because some hints are specific to the outlines and and the baselines, and they use them. But when I want to put this into my query, I probably shouldn't use these in my query text, right? Because I would only want to use some hints, but not the outline specific ones. But anyway, so what I'm saying, open a new session, run whatever hints you need, make sure that the query actually runs faster, right? And now when it runs faster, you verify everything is good. What you can do is this. So the SQL ID of my production query is this. The SQL ID of my hacked query is this. You see, I have SQL patch and baseline scripts. I can actually say create SQL baseline. This is using standard Oracle techniques. And for creating such fixed baselines from a known good cursor, you don't even need extra licenses. If you want to use plan evolution and all this magic automatic stuff, you need the tuning pack license. But if you just want to use DBMS SPM for fixing a specific plan, for locking a specific plan, then you can do this. So you see, you take the good SQL ID and good plan hash value, and so good means that this is my hacked query. This is what works. So this is my hacked query, which I have tested. It's good. This is the SQL ID. This is the plan hash value of my last query. That's the good one. And then I will attach it to the badly running production query, right? So this is the badly running production query. So this just created a SQL SQL plan baseline with this name. And I don't even have to flash the share pool. It figures it out, but let's just have it. And now this is what my production queries run. And this is my production query. I haven't modified it at all. And since I had attached basically this bunch of hints to this SQL ID, you see SQL plan baseline was used. So this bunch of this bunch of hints what I just had on the screen are now bound or attached to this SQL ID. And if they are valid, they'll get used. So you see, my production query, which does equals 1, now is using index range scan descending, right? And all the other stuff what was in a batch table and so on, right? So these in production systems with big and complex queries, if there are hints involved, then you probably are not going to come up with 200 completely correct hints for everything yourself, but it's more like that you wanna play around with a few hints, and once you get a good plan which works, then you take the complete hint set and you bind it to your query plan. Okay. And to finish this part, you shouldn't use hints, right? You just wasted 3 hours learning about how to use hints or where things can go wrong, and you shouldn't really use them. Well, as a default decision, don't use your hints. Figure out where the cost estimation goes wrong. Figure out where the row count estimation goes wrong, and so on. In modern days, you fix things in a different way. And sometimes you do multi-column stats. Sometimes you add a histogram. Sometimes you remove a histogram. Sometimes you enable dynamic sampling, right? So just to get better estimates for optimizer. Or sometimes you add columns to the index. Instead of forcing optimizer to use a mediocre index, why not add more columns to this index? So it would be so irresistible to the optimizer so that it will always use it, right? So, but nevertheless, sometimes you do, need to experiment with the hints, and that's why this session, right? But starting from Oracle 18, maybe it's Oracle 18 or 12.2, I don't remember. This is this used to be an undocumented parameter. Now it is a documented parameter. And you migrate from Oracle 9.9 to Oracle 19, and it's kind of slowish and so on, because you have accumulated thousands of hints from old days before people even knew how to use cost-based optimizer right. And people are often so reluctant to change anything because, for the last 20 years, they spent years and years to get the system to even semi-stable state. And they don't want to go through the code and remove all the hints and do all the testing in the application code. They might not even know everywhere where hints are coming from. And the solution is here. Either you create SQL patches for individual queries and you say, create a SQL patch. Let me just do this. So let me take this is my hacking query. Like, let's say this is my hacking query and I don't want to use it. I don't want it to use this hint anymore. So the SQL ID of this query is this. I can just say, create SQL patch. This is the SQL ID, optim, ignore embedded hints. Right? I just created a SQL patch for this query alone, that whenever anybody runs it again, ignore any hints that are embedded in the text. You see? I have no idea why it's still using it. Should use the other plan now. But the patch apparently was used. Let's see. Patch apparently was used. But maybe I had a syntax error. So let's practice what I just preached. So let's use the patch is used. There is a syntax error. Optim ignore embedded hints. So that was ignored, and then optimizer came up with this sending. Okay, optimizer still used my hint here because this thing was not recognized. And ignore optim embedded hints. So, I just failed the rule number 2 of my levels of invalidity, yeah. So I should maybe use a correct hint. So I said, ignore optim embedded hints. I had optim ignore embedded hints. So, obviously, if I'm doing a stupid thing, then optimizer will comply. So I gotta drop this patch. I'll just say drop SQL patch, SQL patch. This is the name what it created, and let's do this one more. So ignore optim embedded hints. I don't have to flush shared pool even though I have the habit. This is because when you create the shared pool, when you create the patch, then existing cursors are sort of marked that they were not using this patch. So when you look it up and wanna use it, then Optimizer realizes, hey, I cannot use old existing cursors because a new patch has been associated with this SQL ID since the last time they were compiled. So so when I run this, well, I guess the old guy got aged out, so I hope so. So let's see. Okay, so this is the query. You see, now my query is using an index unique scan, not this descending range scan, something crazy from past. It's using a proper unique scan, nothing fancy, nothing complex, and my hint what I embedded. So you see, this new SQL patch was used, and my hint was taken as a first preference, from my SQL patch. So before we even went to the SQL text, right? So my ignore hint was honored, and thanks to my ignore hint being honored, other hints in the query text, SQL text, were rejected because I just said that. So you see there, this is unused. Okay. Right, so this is, when you migrate from Oracle like 9 or 10 or whatever, to a modern version, and and you use better stats, multi-column stats, you use dynamic sampling, directives, and plan all this stuff, then get rid of, if everything sucks after an upgrade or when you do performance tests, then just disable. This is now a documented parameter. Kind of set it system-wide, ignore or use an alter session in a login trigger. Before you start tuning anything manually, just disable all hints and run your workload. Might actually work. Maybe 99 of your queries are okay now. All the over hinted queries are fine. Maybe one query goes bad without hints, but at least you only have one query to tune, not 99. So this is cool. All right. So summary. I have an events page now. If you go to my blog, I have upcoming hints, upcoming events. Obviously, my training starts next Monday. I'm actually going to talk about Linux for database stuff at Polish Oracle 600 guys event. Point with Oracle user group, or I don't even remember what the name exactly is. I will add a link here. So it's gonna be a conference and I'm gonna do some Linux hacking sessions because I have a Linux class coming up and so on. And the next run of our virtual conference, which we did in April, is still gonna happen in end of September again. We'll probably go deeper in there or have a slightly different angle to the same topic. And I still have left the early bird rate, sign up rate available as well. So, if people want to sign up for that. And I didn't even get to, Mohammed, let's use Mohammed's blog entry as a white paper for this event because I only have slides and a lot of hacking. So I'll paste this in here. So Mohammed actually has an example, kind of one of the more complex examples where so basically, yeah, you can read it yourself, but you see some things are not valid under the evaluation circumstances, right? So you might want to do this or that, but in some optimizer may ignore your choice, your hint. Not ignore. Optimizer will not honor your hint because it's invalid with some specific way that the query otherwise has to work, right? And transformations affect that and so on. So this is a good article. Once you've gotten some rest, and you can read that. So Oracle honors hints. Hints are directives. They are commands. Oracle must obey them if it's a valid thing to do for the optimizer. under the current transformation choice or evaluation what it will check, right? So all right, so that's all about this part. Let's see, how do we do questions and so on. So yeah, so Mohammed, thanks for pasting in Slack. There is a join elimination article by Tim Hall. Let me see if I just put it in the GoToWebinar as well if some people are not in Slack. Okay. There is one question that if I use a parameter to invalidate hints, if I use optimize or ignore hints, will it also invalidate hints in SQL patches and baselines and so on? And the answer should be no. You always should test, or if it's not like a well-known thing. But if I look into the parameter, you see, when I get my mouse back, see this, and the parallel hints is also cool because, again, as I said, I don't like to have parallel hints within the query text and so on, because that should be more like a session level or workload level thing. Maybe we do it with a logon trigger or something. But those big batch jobs that need to finish fast, they get parallel 16, right? Those reports which need to also finish but not that fast, they get parallel 4, right? And you can do it based on user or based on the service, how they log in, and have a login trigger which uses alter session to force parallelism or at a connection level, right? Or things like that. Or so I don't like having like a hard-coded parallel hint in a query text, because then you would have to change application code just to the query text just to change parallelism. So there's a separate hint for that. That other hints are fine, but ignore parallel hints, right? And especially you are on Exadata. Maybe not everything has to be parallel anymore, because when you have a serial smart scan, then the storage cells do work concurrently and in parallel anyway. So you might not need parallelism kick in at all. And when you have parallel hints in your code, then they may cause trouble there. And you see embedded. So that's the keyword. So when you use this, when you use this, or when you use this hint, that means that only ignore those hints that are embedded in your SQL text, sent by the application. But these parameters don't affect SQL patches and baselines, because these are not like embedded hints. These are sort of injected hints, right? You inject them under the hood. Okay, just going through. One question about help. What version does this help script work with? Any version, because you see, I go to my blog, by the way. So you see, there is a help.sql, right? And actually, Thomas Sroka was the guy who actually wrote the help for most of my scripts. I had such a script for many years, but I never started actually, populating it. And Thomas added like 100 scripts in there, and I added 20 more. So now we have like 820 more scripts, about 800 more scripts to document there. You see, when you do help, you see, it takes a regular expression. You can use list multiple things at the same time, like anything that has latch or lock in it, and so on, and it has usage. But if you look inside the script, if you look inside the help script, it's a union all, because I don't wanna. It's a union all which has all the documentation, and in the end I just have the where clause, right? But only show me these lines from this union all where this thing is true, right? So that's why you don't have to create any temporary tables or anything like that for this to work. Any database you log into, any Oracle database you log into, you can run help in there. And I will paste the link to the chat. there was one question, where we can download the scripts and so on. Again, go to my blog, click on downloads. All my scripts are in GitHub, right? And make sure you star my repo, because that's the currency of the cool kids nowadays, right? I gotta start my own repo as well. So, okay, that's cool. Now it's better.